All right, Professor Jim Schultz here for my Finance 680 students. I wanted to go ahead and record a YouTube video here going through some more problems for you guys, and I thought I would go ahead and knock out these two challenging bond problems that I sent you guys to work on. Just looking over the videos you guys already have at your disposal, I feel like there is more videos for the Chapter 8 material, the stock stuff. So I thought I would go ahead and add a video here going through a pair of problems from the bond section. So let's go ahead and let's get started. Let's take a look at these problems. These are both really good problems to practice, and they're definitely not easy at all. So let's look at this first problem. In the first problem, you're given the current yield, you're given the time to maturity, you're given the current price, and you're given some information about how often the coupons are paid. And you need to find what is the expected price 1 year from today. So to start this problem, you want to start by using your current yield relationship to back out what the coupon payment of the bond is going to be. From that, you can find the coupon payment to be $50, and then you know that that's going to be paid semi-annually. Once you have this coupon in place, you now have everything you need to solve for the yield to maturity. That's the only piece that you're missing. And so once you have the yield to maturity, you'll then be able to solve for the price at any point in time, whether it be 1 year from today or 6 months ago or 6 months later. It doesn't matter. Once you have the yield to maturity in place, because again, remember, we always assume that interest rates do not change unless we are instructed otherwise. And so this area, you're solving for the yield to maturity. Now, everything is pretty straightforward except for maybe N, in my opinion. So I wanted to present the information to you guys a little bit differently in this problem. And so you see that this bond matures in 19 months. So remember, your N has to be in semi-annual increments. So the question is this: how many semi-annual increments are in 19 months? Well, if you actually drew a timeline, which probably would have been helpful in my solution here, but you can kind of visualize what the timeline would look like, right? You know that in 18 months, there are obviously 3 semi-annual periods, right? There's 6 months, 12 months, 18 months. That brings you to 3. But then you have 1 month left over. So the question becomes, how do you represent that as a 6-month time interval? Well, if you have 1 month left over and there are 6 months in the next semi-annual period, 1 divided by 6 is 0.167, or 16.7%. And so that is why you have 3.167 here for the time to maturity in this step of the problem. So when you have all that stuff put in place, you crank out this I, and then what you do is you move to finally solving for what the price is going to be in 1 year, using the same I, obviously the same future value, the same coupon payment, and now you're 1 year later, so 2 semi-annual periods have rolled off. So you're now down to 1.167 semi-annual periods until this guy matures, and that gives you a price of $993.63. So that's how you solve this first problem, which is a really good problem to practice. The second problem I think is a little bit easier. The second problem, you have 3.2 years left to maturity. You know the YTM is 4.2, and you know the current price is 10.76. Coupons are semi-annual. What was this bond's price 6 months ago? Okay, so what you basically need to do is you need to start with your information right now, and as you piece together all the info, you recognize the only thing you're missing is the payment. So you crank in today's price, future value, your yield to maturity, and your N, and just make sure they're on semi-annual time increments, and that gives you your semi-annual coupon payment. From there, you can simply insert the semi-annual coupon payment into finding what the price was 6 months ago. So 6 months ago, the yield to maturity was the same, still 2.1, which is 4.2 divided by 2. Future value is still going to be the same. Coupon payment cannot change over a bond's life, but now N has to be 7.4. And the reason why is because we're now 6 months ago. So we have now essentially added 1 semi-annual period to our time to maturity. So that's why your N here is 7.4, and then you can crank out 1087.55. So this is how you solve the second problem on the challenging bond problem set. So I hope you guys found that useful. Again, these are two really good problems to understand from the bond section. And that's it.